In machine learning, one of the best ways to learn more about your data is by classifying it with what you already know. You can group together a bunch of data based on similar characteristics. Because you already know these characteristics, you can classify the data using supervised machine learning. A very common supervised machine learning algorithm for multi-class classification is kNearest neighbor. This is an instance-based machine learning algorithm, or what's also called lazy learning. With lazy learning, the bulk of the computation happens right before you want to classify your data. The learning doesn't happen continuously. Instead, you run all your computation in one big instance. In a sense, you're saving up all your energy for one big splash. kNN compares something you don't know to what you already have. So, in some ways, you're getting immediately rewarded for the size and quality of your training data. The downside is that this takes a lot of computational power, so sometimes it's difficult to use kNN on very large datasets. Think of it this way. For a veterinary doctor, one of the most difficult jobs was trying to classify the breed of each new dog. There are hundreds of different known dog breeds. Not only that, the dogs aren't that close-minded about who they breed with, so you have a lot of mixed breeds. Each time when there is a new dog, the veterinary doctor would hold it up to several of the existing dogs that were already classified. Then we'd look at some of the characteristics. Maybe it was the shape of their face or the color of their hair. In a sense, the purpose was trying to classify the unknown dog by looking for its nearest neighbor. Another way to look at it is you're trying to minimize the distance between the unknown dog and the known breeds. If the characteristics were closely matched, then there was a very short distance between the unknown dog and its nearest neighbor. Minimizing the distance is a key part of kNearest neighbor. The closer you are to your nearest neighbors, the more likely you are to be accurate. The most common way to do this is through something called Euclidean distance. There is a pretty sophisticated mathematical formula that can help see the distance between your different data points. Now, imagine you had millions of dogs and you wanted to classify them based on their breed. To start out, we might want to create two key characteristics. These will help you classify dogs that share the same breed. These are often called predictors. So, let's use their weight and the length of their hair. Now let's take these two characteristics and put them on an XY axis diagram. Let's put the length of their hair along the y-axis and their weight along the x-axis. Let's take 1,000 classified dogs in our training set. We'll put them on the graph based on their weight and hair length. Now let's take our unknown dog and put it in the same chart. You can see that it's not matched with another dog, but it has a bunch of close neighbors. Let's say we use a k of 5. That means we'd want to put a circle around our unclassified dog and its 5 closest neighbors. You can see that if the distance of the other dogs is shorter, you'll probably get a much more accurate classification. Now let's look at the 5 closest neighbors. You'll see that 3 of them are huskies and 2 of them are shepherds. You can be somewhat confident to classify your unknown dog as a husky. kNearest neighbor is a very common and powerful machine learning algorithm. That's because it can do more than just sort dogs. In fact, it's commonly used in finance to look for the best stocks and even predict future performance.